Okay, sir. Good morning to one and all. The beautiful things about learning is that nobody can take it away from you. On behalf of Department of Chemistry, Kongunadu College of Engineering and Technology, we welcome you all for the seminar on biological plastic degradation, current and future perspectives. Biodegradable plastics are plastics that can be decomposed by the action of living organisms, usually microbes, into carbon dioxide, water, and biomass. As more companies are keen to be seen as having green credentials, solutions such as using bioplastics are being investigated and implemented. The primary purpose of biodegradable plastics is to replace traditional plastic that persist in landfill, which harm the environment as well as health. Definitely, this seminar will give you a clear outline about the biological plastic degradation. And welcoming is like a perfume which makes the whole gathering fragrant. Now I would like to invite Mr. V. Sriram, HOD, Department of Chemistry, Kongunadu College of Engineering and Technology, to propose welcome address. Welcome you, sir.
Thank you, ma'am. Good morning, everyone. A very warm welcome to all for this one-day national level seminar on biological plastic degradation, current and future perspectives. I'm extremely pleased to welcome our beloved chairman, Dr. PSKR Pereswamy, sir. I welcome you, sir. Respected principal, Dr. R. Ashokan, sir. Welcome you, sir. I would like to extend my sincere and warm welcome to our Dean R&D, Dr. J. Yogapriya, ma'am. Welcome you, ma'am. I feel extremely privileged to welcome our Dean Projects and Consultancy, Dr. S. Vijay Kumar, sir. Welcome you, sir. Next, I would like to welcome our guest today, Dr. M. Selvakumar, sir, Selection Grade Assistant Professor, Department of Chemistry, Manipal Institute of Technology, Manipal. Welcome you, sir. I wholeheartedly welcome our first year HOD, Dr. K. Balasubramaniam, sir, and first year coordinator, Dr. N. Karthikeyan, sir, and heads of the various departments of SNH. I welcome all the faculty members of the KMCT, and also I welcome the lovely audience who came from various institutions as faculty members, students, and research scholars. I welcome you all. Definitely, the seminar will be cheering up the young minds and the listeners regarding biodegradation of plastics. I once again welcome you all for this wonderful occasion. Thank you.
Thank you, sir. Now I invite Dr. J. Yogapriya, ma'am, Dean R&D, Kongunadu College of Engineering and Technology, to give felicitation address. Welcome you, ma'am.
So, respected Chief Guest, Dr. M. Selvakumar, sir, Department of Chemistry, Manipal Institute of Technology, and Dr. S. Vijay Kumar, sir, Dean Project and Consultancy, Kongunadu College of Engineering and Technology, and HOD of Chemistry Department, and Kadaresan, and all the department faculty members of chemistry, and participants from various institutions. Good morning, one and all present here. So, first of all, I would like to thank DBT, that is Department of Biotechnology, who is always accepting our proposal in the field of plastic degradation and healthcare and biotechnological application relevant areas. For the past 1 year, we have received more than 7 proposals from the DBT for conducting very useful informations with relevant to innovative technologies. Basically, DBT always supports the sustainable, that is environment sustainable related seminars, as well as the biotechnological relevant areas. So most of the department have received this seminar proposal. So definitely today's session is biological plastic degradation. The current and future perspective will be useful for you. Most of the research is going on by replacing the plastic. And also our Vijay Kumar sir is doing an biobag relevant. It is an bioplastic relevant research in the industry also. So this is a booming field, and also I request everyone to take care of this seminars Dr. M. Selvakumar sir, who has accepted invitation to take this session. Thank you so much, sir. Definitely, this session will be useful for you. Wherever you are having doubts, and you can ask with Selvakumar sir and also Vijay Kumar sir. So not only the knowledge gathering should be finished within the seminar, it should be go ahead and further research also to be done with this topic. So I request all the participants to involve in this seminar and look for your further research. Thank you so much.
Thank you for your inspirable speech, ma'am. Now I would like to call Mrs. B. Subhashini, Assistant Professor, Department of Chemistry, Kongunadu College of Engineering and Technology, to give Chief Guest introduction. Welcome you, ma'am.
Thank you, ma'am. Good morning, everyone. It's my immense pleasure to introduce today's chief guest, Dr. M. Selvakumar, Assistant Professor, Department of Chemistry, Manipal Institute of Technology, Manipal University, Manipal, Karnataka. He did PhD at National Institute of Technology, Karnataka in the year 2009 in the field of biodegradation, electrochemical and solution properties of some polymer systems. And he did MPhil at Bardhasan University in the year 2005 and PG at Bardhasan University in the year 2000. He done UG at Bardhasan University in the year 1998. He has versatile research in the field of chemical and electrochemical in synthesis of nanostructured conducting polymer used for supercapacitors, polymer electrolytes, and rheology of polymer solutions. Electrocatalysis for hydrogen and oxygen evolution reaction. Synthesis of organic sensitizer and ionic liquid doped polymer electrolytes for dye-synthesized solar cell. Then synthesis of new perovskite materials for solar cell applications. Development of hybrid links for flexible thermoelectric generator application. Mental organic framework for carbon captures. He has various achievements like NITK Junior Research Fellow from July 2005 to June 2007 and NITK Senior Research Fellow from July 2007 to August 2008. He received Best Oral Presentation Award in International Conference on Electrochemical Power Systems held at Thiruvananthapuram in the year 2008. Best Researcher Award in MIT, Manipal University in the year 2013. Best First Award from Indian Institute of Science, Bangalore in the year 2016. He received IEEE UG Supervisor Award from Indian Institute of Science in the year 2021. He received Founder Project from various funding agencies worth 30 lakhs. Guided 8 PhD scholars and 32 MSc students. He had publications, 2 books and 72 international journals, 2 patents, 37 conference proceedings and presentations. Now, I hand out the section to Dr. Selvakumar sir. Selvakumar sir, welcome to you.
Yeah, thanks, madam, for your nice introductions. I hope I am audible.
Yes, sir.
Yeah, I'll share my presentations now. So I'll turn off. Can I? Do you want video should be turned on, or can I turn off the video?
It's your wish, sir.
Okay. I think better I'll turn off the video and I'll talk. If there is any clarifications, at that time I'll turn on the video because it is helpful to continue the flow of the talk very nicely.
Okay, sir.
Yeah. I hope my slide is visible, right?
It is visible, sir.
Yeah. Okay, I'll continue my talk. And thanks for your nice introductions and the invitations. And we are going to discuss the plastic degradations, current and future perspectives. And in addition to this, the recent work, what I am doing, that also I am going to show, because why I want to show the recent work, because everyone want to know that what is the recent work it's happening. That also we are going to discuss in the end of the sessions. Okay. So of course, you just put it in a Google Scholar and you will get the entered informations for each and every faculties. And even your faculties also, you can search it in a Google Scholar. So entire information you might be get it. And this is what the present scenario. So I am coming to the talk directly. Of course, this cartoon I have taken from the Tinkle book only. You just see that our Supandi is taking with plastic bags and going for buying, say no to plastics. Then he came to the plastic bags, to paper bags. Now the cartoon images, it's seeing save trees, right? It is a, of course, as a layman point of view, whether I can use a plastic or not, or whether I can use a trees or not. Of course, you might be seeing that, right? Erode and Coimbatore, and due to road construction, many of the trees they have cut down. And now we are feeling so much hot, very difficult to living also. So that much due to global warming, that temperature of the present, when 2000, what is the temperature? It's totally different. In fact, 2000, when we reach 12 to 12, 2 o'clock, what we are getting the temperature, now we are receiving 8 to 10 itself. And 2 to 3 o'clock, no one will be there in outside at all, because that much temperature was there, particularly in our places. So what we have to do, right? How we can pollute, how we can avoid the plastic, how we can degrade the plastics in the environment, right? There is no proper, you can't simply ban the plastics, because there are a lot of industries who are involving in that. And in fact, again, that also it's giving a very good job opportunities. We can't just ban it entire plastics. And of course, we can't, okay, the next alternative options, we can't take directly the paper bags or using a trees, whatever the bags, we can't use it. What is the other alternative, alternative solutions that we have to think that? So for that only today talk I am going to address, right? So plastic bags are non-biodegradable and pollute the soil. Why it is not biodegradable, right? You can imagine the structure of ethylene. In many of them, you might be knew that CH2 and CH2. So the continuous n number of molecule might be 100 or 200, whatever it may be, right? So with respect to, we are going to call a low density polyethylene, high density polyethylene, whatever it may be. So there will be no chance to break the carbon nitrogen bond, right? So carbon carbon bond, very very difficult to break. That's why we can't be able to degrade it. I'll tell you when I'm showing some of the interesting results in the plastic degradations. And I used to read one articles when I'm doing this work in 2005 to 2008 in NITK in Chemsosphere. It's a very good journal in Science Direct. That author has did more than 25 years, right? 25 years means imagine that, right? Entire career, he did the plastic degradations. In end, all the approach he has did, and in the end of the time, he has honestly he has written. After I did all the effort, also I couldn't able to find the degradations in that, in the plastics. That's what it nature, because carbon carbon continuously it is there. You can't able to do any hydrolysis. If you take any of the organic chemistry people, they may tell how to synthesis means. See that any hydrolysis group is you go for the hydrolysis and make it to the product and go for the derivatives. That is the way of simplest way of synthesis of organic compound. Or else they may do a charcoal derivatives, or they may do a heterocyclic compounds, because breaking the new molecule it will be very difficult. That we are not going. I'll discuss in the plastic biodegradation. So this is a scenario. So how I am going to achieve this, right? I, of course, I want to. I don't want to ban entirely plastics. I don't want to take entirely from the trees or paper bags. What I'm going to do is, what I'm going to, of course, at least some slight degradation should happen. That's what the native of the work. We want to try to address that. Our research, our PhD work has to be give some small solutions which you might be fulfilled. You remember that earlier might be people used to do 4 to 5 years or 7 years, right? Now it is not. It is a time bound. Using a 3 years, whether you are able to complete, because there are very good job opportunities outside there. Can throw out more than 5 years, 6 years doing the PhD may not be helpful. Okay, so that we'll address later. So that this is what my content of the talk. The first one is molecular interactions of a polymer and a solvent. See, I am going to take one polymer and I am going to dissolve in a particular solvent. So where I am taking a solvent, whether the particular molecule, particular polymer molecule has a interactions or not, that first I got to do that. Of course, it's a very simple solutions. You can't ban fully plastics, and you can't take a fully trees also. What I am going to do is, I am going to blend the plastic polymer with biodegradable polymers. So that means the blend miscibilities we have to discuss, right? Because all the ratio, it may not going to give a miscible. Because where there is a miscibility is there, then only proper interactions of the natural polymer and the synthetic polymer, proper interactions will come. Then we have the chance to degrade the synthetic polymer. That's what our assumptions. But what it has happened, that we'll discuss later. And of course, see, when I did this work and I discussed with Professor Kalyana Sundaram in Aragappa University, Tamil Nadu, Karaikudi only, and he has warned me that time itself. Silvakumar, you are going to, after complete your PhD, you are going to take your thesis and you have to go for the various institute and you have to try to get a job. So that is the case if you did the biodegradations, polymer blend miscibilities. And of course, we can tell, but whether you may get a job opportunity or not, you have to think. He has won that time itself. When I'm taking 2005 itself, he has a very good theoretical physics, and he has retired that time, might be 62 years old that time itself. He has won that. So then I looked at how this polymer blend I can use it for some useful applications. That it is helpful to get a good citations and good grant in the funding agencies. That also we are going to discuss. And of course, not only this limitations, recent research work we are doing in various fields, it might be helpful. So just for the awareness, I am going to discuss for 5 to 10 minutes. So just I am introduced and I am enter into my topics. So this is what my content of presentations. Yeah. Outline of the work. I hope I am audible. Can I continue?
Yes, sir.
Yeah. Fine. So outline of the work. See, as a chemistry point of view, if I told you go and prepare the 1 normal sodium chloride solutions, everyone will see the molecular weight and the molecular weight and equivalent weight for univalent electrolyte. It is same. So everyone easy to prepare. The same thing I am telling, you can take a 1 normal, you prepare the 1 normal polyvinyl alcohol. Is it possible to prepare 1 normal polyvinyl alcohol? The molecular weight of the polymer might be 10,000 or 25,000 or 50,000, 1 lakh. So that is the case how I can prepare the solutions, right? Because first we have to discuss the polymer, what I have taken the synthetic polymer or biodegradable polymer, whether it is properly dissolved or not. That I have to check. Then only I can go for the second steps, right? I can go for the polymer blend studies. If there is no interaction between solvent and solute, then itself we can throw it, right? Because that it may not be helpful to go for any further work. So that means I have to prepare the polymer solutions. So preparing a polymer solutions, it may not be a normality and molarity. percentage of solution. Either you have to concentrate on a weight percentage or volume percentage, right? That means 1 gram in 100 ml. So that might be act as a 1% of solutions. So using that, I have to find out whether the solvent and the solute, solvent means either you can take aqueous solutions or non-aqueous solutions, water soluble polymer, water insoluble polymer. Water insoluble polymer means you got to take a non-aqueous solvent, benzene, toluene, DMF, THF, whatever it may be. So then in that solutions, whether it has a proper interactions or not, that we are going to find out using some physical parameters, right? You can find out the density, viscosity, ultrasonic velocity, and the refractive index. So density and viscosity are the one you might be new that. What do you mean by the ultrasonic velocity, right? Why I am explaining this work means I am coming, the idea of the talk, I knew that it is a biodegradations, but these type of work, it can start any of the college, any of the arts and science college, because many of the arts and science college or many of the engineering college, they may not have facilities. It's very easy to start this type of works, and even this type of interactions, you just see the Journal of Chemical Engineering, ACS, and Fluid-Based Equilibria, and a very good journal, even Rangmier, they are publishing with the polymer and solutions interaction. Only thing is, you go to concentrate in your calculations. Okay, what is ultrasonic velocity? I'm going to create the sound in the solutions. That means I'm going to create the velocity in the polymer solutions that I'm going to monitor whether it is helpful to give interactions or not. Refractive index, of course, you might be new that. So when the radiation is passing to different medium, it might be get refracted. So those physical parameters I'm going to find out in series of solutions. Then I'm going to check the calculations whether this particular polymer has a proper interactions of the solvent or not. That's what the idea of the work, right? So calculations of a secondary parameter like interaction parameter and solvation number. Don't worry about the calculations, right? It is very, very simple calculations. And one more hint I'll give you. Please don't, for the calculations, small calculations, don't use a smartphone and calculator. Try to work out in your observation notebook. Then your way of working and way of calculation knowledge, it might be helpful. And don't use an Excel sheet to plot a graph. Please try to plot in the ordinary graph sheets, because I'm seeing now also the students, they can't be able to give a proper title of the graph and what is the x and y axis, what is the unit of that. They may use to forget about it. So always use the classical method. Once you get a familiarized, you can use all the sophisticated techniques, because everything we have to use it. Okay. But the preliminary for 6-month work, you try to work out in your observation notebook only. That it might be helpful throughout your career. Okay. So this is what the parameters I am going to find out. Okay, how this parameter, it might be helpful to find out the proper interactions of the polymer and the solvent. That we are going to discuss now. Right? You see that the first example what I have given, you can take a sodium chloride and put it in a water. Easily it will get dissolved, right? Imagine that the same thing, I am taken a polyvinyl alcohol and put it in the water, it will get dissolved, right? Or you can forget the polyvinyl alcohol. You can take a polyvinyl chloride and put it in a DMO. It won't get dissolved at all. So that is the case how I'm going to degrade this, right? So idea behind that the plastic has to be degraded means either you have to do hydrolysis or either it has to be dispersed in the solutions. Then only the next steps we can achieve that. If it is not get dissolved itself, we can't do the work at all. So that's why I have taken this solvent solute interactions. So what I did, so that means it is not easy to dissolve. The solvent should be, that is solute, what I am telling a polymer, it should be immersed in the solvent. Then the solvent induction has to be takes place in the solute. Thereafter some interactions might take place, right? Weak interactions, dipole-dipole attraction, or inter and intra hydrogen bonding between the solvent and the solute molecule. Due to that, it may get dissolved. It may not get dissolved. Forgot about it. It won't degrade at all. So we got to see some other alternative approach. That also I did. That also I'm going to explain now. Okay. So, okay, once it's get dissolved means what else it's going to come? Change in free energy. What is the heat content of the solutions? What is the entropy of the systems? That's what it's meaning, right? So whenever solute it going to dissolve in a particular solvent, change in free energy is going to take place, right? Either exothermic or endothermic. You can just observe in your test tube or a beaker, you can able to find out either exothermic reactions or endothermic reactions might take place. Using that concept, we have derived the equations, right? Change in free energy equal to of course gives Helmholtz free energy G equal to H minus Ts. So N1 of a solvent molecule, number of solvent molecule will get dissolved to the so many segments, number of polymer molecules, how the interactions it might comes or not. Okay, so that's what this is a tedious calculations. I'm not going to explain these calculations, right? Assume that n number of molecules of the solvent I have taken and dissolved in n number of solute molecules. So what is the change in free energy? What is the volume fractions of the solvent and polymer? Whether it has a proper interactions of a particular solvent or not. Of course, this entire work as done by Professor Kalyana Sundaram in Aragappa University. I went and discussed with the sir and he has explained 2005 itself, right? So there itself I have corrected the calculations and the physical chemistry calculations. That time I have corrected from him only. Thereafter I understand the calculation, then I worked out in for my work. Okay. So this is what you see that it's a lattice site for a low molecular weight, easily it will get NaCl means easily it will get dissolved. So in the lattice parameter, so in low concentration, distribution easily, and high concentration might be number of molecules will be more. But you just see that in the polymer solution, in the lattice parameter, like that it will be there. So the breaking of the chain, it is not so easy this case. So that's why we are finding these parameters and other things, right? So using 1, 2 means the polymer and the solvent interactions, and with respect to viscosity and relaxation times and molar volume of the solvent. I'm not, because if I'm explaining these calculations, it will get bored. I'm not interested to explain that. So if it is comes any theoretical point of view, if you want to explain, that times we'll see. Later we can see that. Or your teacher might be explained that. Yeah. So we have put the limit and a psi, that is volume, that interaction parameter using these calculations, whether the polymer has a proper interactions between the solvent or not. We have put the limit. If there is a greater than 0.5, using this calculation, if you psi value, if we calculate greater than 0.5, there is a no interaction between the polymer and the solvent, right? If, okay, 0.5 to 0.6 might be some interactions. If equal to the 0.5, definitely there will be interactions between these two. If less than 0.5, strong interactions between these two. So the first identifications I did, what I did. So I find out what I have taken the polymer as a interactions or not. You just see that this is a series of calculations, right? Everywhere you go to get a linear trend. If you take a polymer and dissolve in a solvent, the viscosity, density, refractive index, if you get a linear trend, definitely it might have interactions. If you are not getting a linear trend, non-linear trend, right? Definitely there will be no interaction. That is a simple identification. You just see that psi value. Normally we used to calculate in a two method of calculation, either viscosity and relaxation time. Right? This is how means. Suppose if you are synthesizing a compound, first you have to take a NMR, then proper chemical shift is there or not, then you have to take a mass spectrum, right? Fragmentations you got to identify. Okay, we identify proper everything. You can go for the FTIR, proper stretching frequencies. Then using CHNS analysis, carbon and nitrogen properly if there is or not, with the parent molecule you have to calculate. Then only you have to prove The same idea only, the same calculations you got to approach in a 2 or 3, 4 methods. And all the method, it has to comes in the same value. Because one method, if it comes a different value, and other method, it comes a different value, somewhere else it's not. That's what. If there is a linear trend, right? It's a look like your carrier improvement, it comes in the linear trend, right? It should not be a 90-degree. 90-degree means always dangerous. If there is a non-linear trend, there might be a reason, right? In your carrier, if there is a non-linear trend, if it is a decreasing, there might be a reason. You got to find out and you got to rectify, and again you can try to approach to the linear trend. That's what the meaning for either it might be a research or in a regular work. Right. I have taken a PMMA and a PEG. So one PEG is a biodegradable polymer. PMMA, it's a synthetic polymer. And a THF, and of course PEG is water soluble. And I have taken to prepare the solutions because the reason is why I have taken a non-aqueous solvent THF. You can PEG to get dissolved in water, but PMMA it won't get dissolved in water, right? So both the things has to be takes place, and aqueous when you are dissolving to preparing a plastic film, it will be very, very difficult. So when you are preparing a proper composition and thereafter you have to pour it in a petri dish, then you have to keep it in a oven, thereafter you have to dry the solutions. So water means 100-degree Celsius, TH means with respect of the boiling point. You have to reach the oven. In the reach, you have to keep the temperature at a particular boiling point of the solvent. Thereafter, solvent will get evaporate. You may get a plastic free. That's what the idea. So then PVC, you see that everywhere I have taken one synthetic polymer and one biodegradable polymer. What I have taken the polymers and the solvent as a very good interactions. Okay, now we can go and prepare the polymer blends. If it is comes the psi value greater than 0.5, or if I am getting a non-linear trend in my physical property of the solutions, I can throw out, right? No need to continue the further work. Okay. So polyvinyl acetate, PVAC means, CAB means cellulose acetate butyrate. Right. This is what my aim of the work. Of course, we'll see whether we got a proper degradations or not. That's what it is not so easy to degrade. You'll see in the end of the presentations. Yeah. Conclusions for the interaction studies. So polymer solvent interaction parameters, of course, it shows with respect to at a particular temperature. So from 2005 onwards, we have published. See, whatever you are doing the work, please try to publish in any of the journal, because we have the limited knowledge. That limited knowledge, when it going to expose, when you are going to discuss with other people only. So you have the whatever you did the work, when you are sending to the journal, it will go to the subject expert. 90% it will go to subject expert. They will ask some very good questions. If you try to find out the answer for those questions, again your research knowledge and further work, it will be in the progress. So whatever I am doing the work, everything I use to publish. And nowadays they will send some 3-page comment also. We don't worry about it. We'll take time to address all the questions 3 to 4 months, right? And we will address that, and it will get tried to later. They will everything. You have to give a proper justification and proper satisfaction for the reviewer. That itself is one of the big tasks. So you see that almost all the work, it might be get published in a good journal. Either it might be an Indian journal or international journal. Don't worry about it. Please try to communicate your work to the journal. Don't keep it as such, right? And open your mouth and talk with your colleagues and neighbors and your friends. Then only you may get your vision might be improved. That. Yeah. Next one is okay. The first aim we have achieved. What I have taken a polymer and the solvent as a quiet interactions. Now I am doing a, okay, that means PMMA and CAB, I am cellulose acetate butyrate, I am going to take it in a common solvent. Right? Miscibility means that's what polymer blend things two different polymers you are going to dissolve in a common solvent, then make appropriate compositions and make a polymer blends. Our aim is, because of this biodegradable polymer, at a particular miscible regions, whether the synthetic polymer get degrade or not. That's what the aim of the work. For that reasons, we are doing this work. Okay. So polymer blends. Why polymer blends? So synthetic polymer has some applications, and biodegradable polymer has some limited applications. So when you make a blend, you have the chance to get both applications, right? Because it is very degrade the synthetic polymer alone. So the next attempt we are doing, why can't we take a at a particular miscible regions whether it has get dissolved or not? That's what we did, right? So we want to so that's what we did, the polymer blends. And instead of synthesizing a new polymer, right, whatever already existing system, how we can degrade that we try to do one small attempt on, right? Whether we succeed or not, later we'll see, right? There are two type of possibilities, miscibilities, right? Either in a upper critical solution temperature, both the polymer in a particular temperature, they may get a one phase, that means miscible phase, or in a lower temperature, lower critical solution temperature, both the polymer at a particular solvent, they may get it. So you got to find out where exactly you will get a miscible range. In a non-miscible range, do a degradation studies, no use, because synthetic polymer and biodegradable polymer in non-miscible region, it will be separate only, right? So like a marriage made for each other, right? So you have to understand both of them, then only marriage will be continue and you may get a fruitful life. If there is a no interactions between them, definitely it might be went to divorce, the same case only. So at a particular regions, only both of them may get a proper interactions, the same thing, right? So earlier cases, here also there are tremendous calculations using Flory again calculations. We can find out the miscibility studies where at a particular ratio the polymer might have a miscibility studies. Now that trend is stopped. You can prepare different ratio of the polymer. Say for example, 100% of PMMA and 0% of CAP. Then 90% of PMMA, 10% of CAB. Like that, you can vary for 10 different compositions, 80% of PMMA and 20% of CAB. So with respect to gas transition temperature, it has to be so a linear trend, right? If there is a linear trend, proper miscibilities might be that should be taking place, right? If there is no linear trend, there also you can stop, no need to continue the work, right? So the DSC you can take and try to find out. Of course, one more tedious method is that also I'll explain that. You see that in some cases linear and thereafter it doesn't linear. That means this regions you can find the miscibilities. You see that here non-linear trend, or you can take one extrapolations from here. So from year to year you can tell the linear trend, and that region it might be a miscible. That region we can tell the compound, both the synthetic polymer and biodegradable polymer might be miscible in the regions. If there is a non-linear trend, we can forget about it, because there will be no miscibility studies. Further doing the work, it may not be helpful, right? We can cut down, right? Of course, just for the calculations purpose, because these type of work, if you calculate the viscosity, ultrasonic velocity, and the density and the refractive index for any of the solutions, for not only for the polymer and the solvent, you can take it for the protein and with the aqueous solutions, protein interactions, protein DNA interactions. You see that if you find out these physical properties, you can able to publish in very high impact factor, fluid based equilibria, Langmuir. That's why I am explaining these calculations. it might be helpful to do or start a new research work in your college itself. No need to search, because you are going to find out the physical property of the system. Then you are going to do the calculations. Thereafter, you are going to tell whether proper interaction or not. That might be helpful to develop the process chemistry in industries. So just we'll see some another 5 minutes. I'll explain a small calculations. Right, I have prepared from 10 different ratio of the solutions. Right, normally 2% of solutions I'll prepare PMMA 2% and CAB. From the 2%, I'll vary the I'll prepare this ratio. Then 2%, next I'll go to 1.8, 1.6, 1.4, 1.2, and less than up to point where I can go for minimum solubilities, up to the minimum solute I can take 0.2%. I'll vary all the composition and I'll do the viscosity, density, refractive index. So of course the work is very tedious, right? Unless if you put the proper effort only, you can do that. Now the trend is not like that. If you are able, if your management is helpful, if they are able to buy one Brookfield viscometer for 3.5 lakhs, the everything with the help of spindle, even 0.1 ml, you can do all the characteristics immediately. So the again within in fact, when I 2005 when I started, I did the entire work 1.5 year for solution compatibility studies. Thereafter, one of my junior as he has joined. My guide purchased Brookfield viscometer. Within 1 month, he has completed the entire solution studies. So there are good sophisticated instrument is there. You can try to use it. Right? Then blend miscibilities. You have to again 2 or 3 different methods, heat of mixing, and there'll be proper interaction parameter we have to calculate. So this is calculations weight, and you have to substitute in the respective place only. Don't worry about it. These are Excel sheet. You can make a column, and if you properly substitute the formula in the respective place, you can able to find out the interactions. Right. So you see that this is the proper, there will be no interactions. That means 80, 20, 50, 50, 20, 80, there will be a proper linear trend. Whereas here, there is no proper linear trend. So wherever linear trend is there, we can able to identify only those ratio you can prepare the polymer film for the biodegradation studies. If there is non-linear trend, that ratio, please no need to prepare it. Okay. So this is again mu and alpha, both case it has to be get agree value, chitosan and PEG, and prepare in the where acetic acid we have prepared the solutions, because chitosans acetate, that only it will dissolve in acetic acids, right? So that normally we will tell us CS means chitosans, of course acetate of chitosans and polyethylene glycol. And again del B and del KAB. So all the cases it has to give a same value. If there is a negative value, the negative value means, what do you mean by the negative value? There will be a no interaction between the polymer blends. Okay. Then density and the refractive index. You see that wherever the non-linear trend, that ratio under we can cut down. When you increasing the temperature, the linear trend is affecting. So that means 40 and 50 degrees Celsius due to the presence of polyethylene glycol might be melting might takes place there. That's why the linear trend is affecting. Okay. And of course, you can take a FTIR and see the stretching frequency properly, whether any intensity of the peak is getting increasing or not. And of course, I did the DSC also. You see that with respect to the concentrations of the content is varying 90, 10, 80, 20, 70, 30, 60, 40. The TG also it's shifting. So that means one linear trend we can approach. At least 3 proper degradation film we can able to prepare this case. Right? Of course, this case chitosan PEG both are. PEG is a synthetic biodegradable polymer. Chitosan is a natural biodegradable polymer. That case also you can try. Instead of using a plastics, you can try to prepare this type of polymer film also. So conclusions. So the result indicator, the polymer blends are miscible in the ratio of 90-10 and 80-20 in the entire temperature range. Where we are getting 90-10 and 80-20 only we are getting miscible. The remaining range we can throw out, right? And references, and we have published here e-polymers, and in fact Journal of Applied Polymer Science also we have published, and nearly 4 to 5 papers we have published in these studies. Yeah. Now, what do you mean by why I have taken a biodegradable polymer? Very first itself I have addressed that. So if you take a polyethylene, there is a no chance to hydrolysis. Carbon nitrogen and carbon nitrogen, the carbon doesn't going to break at all. So where if you take a polyester, COO, so you can do a hydrolysis very easily. So a polymer which undergo decomposition due to biological activity or the enzymatic actions of a microorganism, it might be called as a biodegradable polymer. Might be aliphatic polyester, aromatic polyesters, polyvinyl alcohol, polyethylene glycol, cellulose, gelatin, chitosan, right? So those things, natural biodegradable polymer, some of them they will call as a natural biodegradable polymer, some of them they will call as a synthetic biodegradable polymer, some of them they will call as a plastics. So our aim is we want to degrade that. How to prepare the polymer blend freeze. So we are coming to the degradations now, right? How we, because we first I address first 15 minutes I address that our polymer has a proper interactions between the solute, and then the next 15 minutes I have addressed that. So we are going to prepare the blends, how to identify in which ratio it has a proper miscibilities. Okay, that we have identified. Now our aim is, what our aim is, we have to prepare the polymer blends. So can I continue, or you following?
Yes, sir.
Yeah, I'll continue that. So biodegradations of a polymer blend films. Yeah, 2% of a stock solutions, PMMA and a cellulose acetate butyrate. And I have prepared in a common solutions, DMF. Then again, you can prepare now, you have the chance to find out which ratio it has a miscible. That ratio only you can prepare the polymer film. That means 8 ml of PMMA and 2 ml of CAB. That is 80 into 20. That is 8 is to 2 ratio. And keep it in a petri dish and 1 hour, and DMF boiling point 116 or something. At that time, so 100 degree if you keep it, slowly it will get evaporate. After sometimes all the solutions it will get evaporate. Only you may get a blended free. That also in the miscible regions. That film we have taken for the biodegradation studies. Of course, biodegradation studies means the approach was good. See, 2005 or 2006 I did this work. Recently, this work it got published in Polymer Bulletin. 2022 it got published. Right. The reason is we did all the biodegradation studies. We have taken a NMR, GPC, and of course FTIR, all the sophisticated organic chemistry, whatever the techniques they will use, that we have used and tried to find out whether degradation taking place or not. And finally, you have to find out the thickness of the film also, because why means then only you can able to came to know that when you are doing the weight degradations, whether it's properly dissolved or not, right? So first we can go for the classical method. There are two kind of method. One is a classical method and another one is a bacterial method, that is biological degradations method I did. So classical method means weight loss method, right? You can take a soil from your nearby garden. So I have taken NIT garden soil only, and I find out what is the pH. So what is how in the soil means you can disperse the soil in the beaker and add aqueous solutions, and you have to find. Then thereafter, what you have prepared the blend film, you can keep it in the soil. And a desiccator, the soil has to be kept in a 20% of the moisture. And every 10 days and 15 days, 20, 30 days, I'll take the film out and dry it. Thereafter I'll take a constant weight, right? It is not the work look like a easy, right? But if you want the reproducibility, sometimes what it will happen, 10th days you may get the some weight. Normally if there is a degradation, 20th days the weight has to be lost. But sometimes what happens, due to the sampling mistake, the 20th days the weight might be increased. Why? Because it may not be dried properly. So whatever the moisture, if it is there, that is how to dry it. But there is no proof at all, right? You can just put it due to moisture, any compound, there is a chance to weight loss. How you can prove that because of this crude method? I can how you can tell the plastic went to degradation? That is a case. Almost all the material it went to degradation within the 30 days. How much I am telling? So 3% I am telling. That means this method can't be reliable at all, right? So how I can whether okay, I have taken a blended film. So whether it's a degrade plastics or whether it's degrade only biodegradable polymer, that also questions has to come. So both the things I have to address that, because even though you have taken the miscible range, whether the synthetic, what is the proof you are showing the synthetic polymer get degraded or not? That's what the question is. Okay. Just a second. I drink some water and I'll come back. Yeah, sorry. Yeah, I hope my slides are visible. Can I continue?
Yes, sir.
Yeah. Next, we are going to activate a stretch. So activate a stretch means aerobic water, right? So you can correct it in any of the industries you may get, right? Microorganisms, aerated water. That water, the same film we have did. And of course, here also it shows degradation. But these and all, it's a crude method. We can't able to tell whether the plastic get degraded or a biodegradable polymer get degraded. Our idea is we shown the miscibilities. So we have the chance, why can't it may have the chance to get the degrade the synthetic polymer. That's what the meaning here, right? But you have to give a proper justifications and you have to give a proper proof. Okay, enzymatic degradations. Here what you mean, what we did, we have taken a buffer solutions and directly procured the repaste from sigma rich or the robochemical, even small chemical repaste under, if you purchase in a sigma rich, it might be very costly. So many of the chemical will be available in lower vendors. Please go to for the local vendors. You might be get in very cheap and you can do the work. So normally first we'll try to get it in a local vendor only. Sometimes in manuscript they are asking proper proof. That time you can buy good quality, right? Instead of you can buy instead of laboratory reagent, LRR grade, you can go for analytical reagents, AR grade. So that might be helpful. So we have did and we can find out. But here, since it's a aerated water, film within a 15 days, entire film it will get dispersed and you can't able to get a film at all. So that's why instead of 30 days, we did in 15 days. And of course, tensile strength of the blend frames. So what that time I when this work I did in where instant in you got to prepare the big polymer thing. It is not so easy. Your laptop level you got to prepare. Then only that time. Now you can very sophisticated instrument it came. Small film also you can find the tensile strength. So that time I have prepared the very big film and I went to NIT Calicut. There I did and I did, and of course this also it's showing normally because you are finding in either soil or activated sludge or enzyme, might be some interactions might take place. So every 5 to 10 and 15 days there will be a loss will be there. Either you can take for the weight loss method or tensile strength, whatever it may be, right? This is what our aims. So we have taken a PMMA and mix it with the CAB, and PVC we mix it with the CAB. And okay, we didn't stop only this. Thereafter, we have prepared bacterial enumerations method and enzymatic degradations method. That means, what do you mean by that? That entire polymer blend film I have dissolved in the solvent. Thereafter, how you will do antibacterial activity or enzymatic activities in microbiology lab. The same way I did in the biodegradation studies. After that, I did FTIR and NMR and GPC, whether the degradations has taking place or not. Because the weight loss method, it is not reliable data. We can't stop it. You have to go on through that, whether the synthetic polymer or the biodegradable polymer has went to degradations or not. Okay. So what I did, I have taken a bacterial culture, that is Bushnell medium. If you go for the antibacterial activity, everyone they will give that medium only. So you got to prepare in that medium. Then your polymer blend film I get dissolved. Thereafter I added to the medium, and of course control means without the polymer blend films I take a medium, right? And that is called as a control. Then I incubated at 310 Kelvin for 30 days in an orbital cycle, 150 RPM. So every 5 days, 10 days, 15, 20, 25 days, I calculated the bacteria culture. So the beginning of the day, the observation was quite good, but I don't have a proper evidence still, right? 5 days, 10 days, 15 and 20 and 25 days. Initial days, the bacterial growth was very less. But when the day of progress, the bacterial growth was very high. It is almost matched with the control value. That means that's what I discuss with the people and discuss with the scientists, those who work. It is just for understanding purpose. Might be our brain free may act as a food sources for your Bushnell as an agar medium or your Pseudomonas bacteria in the medium. So medium that is a food for the bacteria. If the medium is not the bacteria, it won't going to live. So that's why it has reached the same control level of the bacterial growth. You just see that I'm showing the diagram for that. Inside this diagram, you see that 5 days, 10 days, 15 days, of course, a year. Each and every cases, initially you may not able to find out the bacterial growth, but later, everywhere you can able to find out the bacterial growth. You see that in the end of the day, it is almost reached the control. The entire polyvinyl acetate and the cellulose acetate butyrate film equal to that. So after 30 days, the bacteria count was high and comparable to the control, indicating the polyblend sample as served as a food source for the mixed culture. Right? Still, we right as per the bacteria growth we are telling, right? But we don't have a proper evidence. There are some good questions you can ask that here also. How it can be? What is the reasons why? What is the proof the bacteria has taken the blend sample as a food source? We don't have any proper proof. Okay, we will substantiate with the characteristics technique. Then we have taken the same thing. What I did after 5 days, 10 days, I'll evaporate the solution. Again, I'll prepare the polymer blend film, and I have taken a FTIR, NMR, and a GPC. Whether any stretching frequency is varying or not. Right? So that's what, of course, there is a changes in the stretching frequency. A, B, C, that is before degradations, and after degradations, you see that the stretching frequencies, it is very, very less, and some of the stretching peak, it is totally invisible. Okay, this is stretching may happen or may not happen. You come for the NMR. You see that before degradations, we couldn't able to get any peak at all in the NMR. where I have taken PVC or PMMA CAB. Directly I have before degradations. Once I prepare the polymer film, and I have given to the NMR and I have taken. I couldn't find out the many of the splitting N Pascal triangle N into chemical splitting. I couldn't find out. Whereas after 38 days bacterial degradations, I can able to find out other small shift and chemical shift values in many places, right? So I can able to find out with respect to chemical shift what is the value, what is the peak value, whether it might be aliphatic protons or aromatic protons or methyl proton. I try to find out and justify it. I match that, right? Okay, might be due to degradation that peaks. And of course, not only bacteria, the same thing instead of bacteria, here I have removed this bacteria, directly I have added enzyme also. The same medium I find out. Instead of bacteria to producing the enzyme, directly if you add an enzyme, whether still the degradations was more or not, that I did. Okay. So that also I have find out. So this is a bacterial degradation peak, and this is a enzymatic degradation. You see that still you can find out number of chemical shift is more in the enzymatic degradation. So this is a control of that. Okay, so that it helpful. Okay, we can able to identify some, but still what type of degradations, what is the fragmentations might take place. These are questions, right? The research at any cost, it won't going to stop. It will keep on continue if you ask the questions. We don't have proper proof that. Okay, of course. Next one, I did the GPC also, gel permutation chromatography. I find out what is the molecular weight degradations. Of course, we can able to find out some 14,000. See, 92,186 only biodegradable polymer I have taken. 14,193, and CAB and PMMA and CAB and PVC, just see that 7,491 and 11,276. Still some question is there. This difference, whether it's due to CAB or synthetic polymer. Still question they have asked, the reviewer they have asked. But finally they told, your approach is good, we can try to publish the work. That's what they have given the chance. Because these questions, they have asked many of the journals from 2006 onward, they are asking, well, what is the proof you are telling, how you are going to prove whether the synthetic polymer went to this much differences or CAB. Of course, I can tell due to the miscibility, there is a chance, but what is the exact proof? You have to prove that. They are asking. So that's why the paper got delayed, and finally they told this approach might be helpful for further researchers. So that's why we are publishing like that. They have to. And of course, we have taken the SEM analysis. These are morphology. If you take any degradation frames and if you show the SEM, easily you may get a different morphology. This and that, it may not helpful whether the degradations may take place or not. So you have to show that GPC and NMR only. Right. And of course, some proof we have to do that, no? Because mechanism always, as a chemist point of view, you have to tell what type of degradations might take place that. So just we have shown that might be, this is one of the way of PMMA and the CAB. Of course, just we have written, right? To confirm the entire studies, again, I got to start the work. Then only I can able to prove that CO2 and CH4. That may not be happen at all. So just we shown that from that standard textbooks only we have taken. This may be the reasons like that we have proved that. Okay, this is a blend studies. Okay, you come to the next questions you may ask. Some synthetic polymer and some biodegradable polymer won't miscible at all. That is a case how you approach biodegradation studies. So miscibility is ruled out. You can't go for and prepare it. You can't check the characterizations miscibility studies at all. Then how you can approach for the biodegradations? Okay, that question that time also they asked in the DAC members they asked. Then we tried composites method. So composite means heterogeneous mixture we mixed with the synthetic polymer and we tried for the biodegradations, right? So your wood is one of the best example for the composites, right? So a matrix and the dispersed space. So one polymer molecule will be there. In that one dispersed space will be there, right? Polymer matrix composites. That is a function of the, that is a part of the composites, matrix and the dispersed space. What I did, melt casting method. I have taken a plastic free, right? You can take any of the plastic. You can try it in your lab also. This is a simple instrument. 75,000 you will get it in the Pune. Some of the company melt casting machines, and you can, they will give a KBR die. It might be available in your FTR rooms. You just go through that. There you will give the cuvette. Like that, they may give us that KPR die. They will give inside. You can keep it your plastics material. What I did, I make a fine powder of areca and banana because that it's high rich content of cellulose. I did in the synthetics methods, blend visibility studies. What I did, I have taken a cellulose acetate butyrate. Why can't take this areca and banana, uh, that leaf I have taken and make it dry for nearly 3 to 4 months. Then using ball milling method, I make a fine powder. Then you know the melting point of the plastics. So up to 250 degrees Celsius you can go here, right? So above one mandel will be there, here one mandel will be there, below one mandel is there. Both the things you can reach a temperature. This is a temperature. Of course, it's showing here room temperature. And inside you can keep your plastics, and above the plastics I kept my areca and banana powder. Then I melted, right? Melted the entire plastics. So what happened, that areca and banana powders, it is exactly mixed, and how you may get a wood, you can able to find out it's a plastic film. That much nice film I got it, right? And inside everywhere it is captured with the areca and banana powders. Then okay, I thought the interest, okay, definitely my chance there to get a degrade. You check it again. I did all the work, right? And of course the weight loss and the bacterial enzymatic method, it has so some degradations, right? Again, before degradations I did NMR, and of course GPC I couldn't. I went there also. It shows very very minimum difference. You see that 92,008 polystyrene areca, PS means polystyrene, and polystyrene banana 89,584 in the 15 days. So might be nearly 1%. But what is the guarantee that 1%? Might be chances are that to come out that areca and banana powder also. So we don't have proper proof that, right? Polyethylene also we have tried and we did. This result is showing, but where we have to give a proper evidence exactly the polyethylene degrade or not. But chances are very very less, right? Even if you approach this method also. So these are the one results. I am telling one attempt only. So before degradations and after degradations. So conclusions, the study in the biodegradations, I am giving a conclusions. The study revealed that the blend shows sufficient biodegradability. The degradation extent was high in the case of blends with the higher content of a biodegradable polymers. New types of composites can be prepared by compositing polyethylene, polystyrene with areca and banana fiber powder. And as the studies indicates, the composites also shows proper degradations. And the recently this work it got accepted 2022. They have told, still we have got confused whether it got degraded or not. But this approach may helpful for other researchers. We didn't show that maximum degradations under. In the conclusion, if you see that 1% degradations may happen only, we have your conclusions, right? And this approach may helpful for some other researcher for doing this work. That's why they finally they accepted this article in Polymers Bulletin, right? Of course, This work, the present scenario, we can't able to do that, right? Because the recent trend is, if you join any of the engineering college due to NIRF ranking, and they will see how many applications you are going to give and what is your career progressions. Everything you have to see that. Everything they will see. Of course, you also has to see how you are going to grow in a particular period. Of course, I didn't stop this work up to this much. What I did, the same thing, I went for the polymer electrolytes, right? Polymer electrolyte, you can see that you can use for the lithium ion batteries, you can use for the supercapacitors, you can use for the fuel cells, right? The same blends I have taken, and I improve the conductivity by the addition of some inorganic salt, that it becomes a blend electrolytes, or the same composites I have taken. Then I added the pill and the inorganic salt, that it has improved the conductivities. Then I work for the supercapacitor studies. This work only it is granted by the DRDO. Nearly 16 lakhs grant they have given, 2011 itself. We have published more than 25 articles in polymer electrolytes. And not only for the blends, you can bring a G license in the polymers, right? So in shops you can find many of the coconut oil look like a gel they will prepare, and you can able to apply in the hair, and you can bring the G license in the polymers with the addition of plasticizer and the inorganic salt, inorganic salt to improve the conductivity of the polymer electrolyte. Forgot about it. This everything it is not there. Directly you can take a polymer and add an inorganic salt, that it may be act as a solid polymer electrolytes, right? So this all the three polymer electrolyte you can prepare and do the conductivity studies and fabricate small batteries and find out charge discharge, cyclic voltammetry, and AC impedance spectroscopy, right? You may get a very good paper, you may get a very high impact factor you can able to publish, right? So that's what we did. The idea behind this work is, we have taken a biopolymers, and biopolymer based electrolyte we have prepared. So funding agency they have given the grants, and then we have fabricated the supercapacitors, right? Supercapacitor means it might have a very high power and very high energy densities. So that's why we are going for the, at the small time it has to give a very high energy. So there are very good applications it is involving. Of course, now the recent trend, I shifted to the flexible electronics, that ISS UG Supervisor Award they have given by from Indian Institute of Science. Everything we converted to the flexible electronics. That work also I am going to discuss. Just some small introductions I am going to explain, because other than biodegradations, I would like to explain for remaining half an hour what is the recent work is going on. That I want to explain that, right? So there are two kind of capacitor. These are fundamentals. So now we will come to blend biopolymer electrolytes, right? You see that what I have taken, starch and chitosans. Both are biodegradable polymer. And I added the inorganic salt. And with the help of plasticizer, and I again improve the conductivities. Then I fabricated the supercap. Of course, how the conductivity of the electrolyte, again you have to prove with the fundamental concept, right? That is proton donor and proton acceptor growth types mechanisms it will be there. That mechanisms I have explained in that, and we try to publish in Electrochem Acta in 2012 itself, right? Blend bio chitosans and polyethylene glycol, where I have this chitosan and polyethylene glycol I started 2006 or 7 biodegradation studies. For the biodegradation studies I started. That I make it as a polymer, biopolymer electrolyte. I have the good opportunity to grasp the grant also. right? If I stop it biodegradations, very, very difficult to get a grant. Or if I stop it the blend studies, or if I start the polymers solvent interaction, there also very, very limited scope. But you have to change your field always, right? How to get a grants. Then only it's possible to get a recent work you can able to work out. So then I using a stainless steel electrode, and one side I pasted the activated carbon. Uh, Fabrication I didn't show that. Of course, if it comes in the other slide, you can come to know that. When I'm showing a flexible electronics, you can come to know that. So using a stainless steel electrode, what I have kept the electrolyte, it is a sandwich method, right? So two bread in between masala will be there. No, the same thing, stainless steel electrode in between the brand polymer electrolyte, I keep it and sandwich that might be act as a good capacitors, electrochemical capacitor. Then you can do a CV and the conductivity studies. So this is a growth type mechanism. In the polymer chains, lithium salt we are adding. So when you are adding a lithium ions, the mobility of the lithium ions, the jump of the cation from one side to another side. So when it's jumping, it might be act as a Lewis acid. When it goes to another cavities, that is another junction, it might be act as a basis. Due to that, the conductivity it's increasing. You got to prove that, right? Simply we can't tell the conductivity got increased by the addition of inorganic salt. So always wherever chances are there, you got to give a scientific proof. Okay. So then I did ionic conductivity studies. So when I have to increase the different temperatures, right, from room temperature to maximum where it went to degradation, some 70 to 85 degrees Celsius, I have to find out the degradation studies, sorry, conductivity studies. And what is the maximum conductivity I can achieve means here, since both are biodegradable polymers, you may not get a conductivity 10 to the power of minus 2 and all, you may get a 10 to the power of minus 4 only, even if you add that, because we have the limited scope to improve the conductivity in a biopolymer. If it is a synthetic polymer, you have the chance to increase 10 to the power of minus 2. Or in your polymer itself, some dopant is there, polystyrene sulfonic acids, some dopant is there. That time the conductivity might get improved. But this case, chitosan and charge, because of addition of inorganic salt, it's getting improved. So it is very, very difficult to improve and get a 10 to the power of minus 2 under. So we used to get a 10 to the power of minus 4 only. No problem. Whatever things we can try to fabricate and show the results, right? And you give a proper justification why it is less. If they are asking reviewer, you can tell, sir, where both are biodegradable polymer. I tried one atom, this much only I got a conductivity. No one going to block it. And the supercapacitor studies, you see that I given 47 farad per gram. The same work now you can take that. Everyone will report the 1,000 or 5,000, right? But we used to give whatever the genuine value we can used to give, and proper charge discharge, and this is a time constant, and you can able to identify where the supercapacitor will act as a resistive. So beyond this region, it acts as a capacity. Beyond this region, it acts as a resistive. That means this region we can use our supercapacitor properly. That means withdraw the energy become more in a particular regions with respect to frequency. And of course, again for charging and discharging, we got to tell the mechanisms. And these are the parameters. You see that this paper, it got published in Electrochem Cacta. It is available in that. Okay. This and all like that we have published some 10 to 15 articles. Thereafter, the same work we can't able to do that. What we did, now the same, you see that what I have taken, polyvinyl alcohol, polyvinyl polymer, pyroridine, blend polymer electrolyte. Again, one synthetic polymer and one biodegradable polymer. Synthetic biodegradable polymer, polyvinyl pyroridine, polyvinyl alcohol and polyvinyl pyroridine. The same thing only I have taken. I am taking from that concept only, biodegradable polymer and synthetic. Of course, gel polymer also I did, because due to time constraining, I am not explaining those things. I want to give one small attempts what is the recent work in going with the help of these studies. Okay, so then we did We have prepared the copper nanoparticles, okay, using 5 gram of polyvinyl. So regular, when you are adding hydrogen nitrate, right? So copper oxide you might be get, right? So oxidizing reagent, reducing reagent when you are adding the copper nitrate, it become the copper nanoparticles, brown color precipitate you may get, and using XRD to conform that. Then this copper, we have prepared the ink, copper based ink, right? We have added one uh, cellulose acetate propionate resin dissolved in a diacetone alcohol. Why you are adding that cellulose acetate propionate? Because you need a proper viscosity of the ink. Then only easily you can print it. If there is a no viscosity in your prepared solution, then you can't able to prepare the ink at all. Then we have added the graphite also, so that the prepared copper nanoparticle is dissolved in 1:1 in this ratio. This ink we use for the screen printing our electrode, right? It is one of the interesting study. That's why IAC they have given best UG supervisor award for this work. And we have started one startup using a flexible supercap. In addition to this, some 3 sensors we have developed. The same method, gas sensor, humidity sensor, and a breathing sensor. That also we have developed. Using the one work, we have developed that. And again, you see that I'm using that Brent polymer electrolyte for the supercapacitor studies. So this is what a screen printing, right? First, you have to take a screen printing of a graphite, and the graphite might act as electrode layer, and thereafter your copper nano current collectors you got to coat it. Then over that printed the copper layer. This is what the screen printing of a copper current collectors, and over that copper nanoparticle you can do. Then your electrolyte it comes in the picture, your biopolymer electrolytes. The right, you can pour the solutions about that. Then you can laminate with the polyester bag. So this is look like your 1 rupee coin is there, no? Like that the flexible device. That's why we have filed the patent, Indian patent also. And this device we can able to sell now, right? Using that same biopolymers only. And we have shown all the characteristics, charge, discharge, AC impedance, cyclic voltammetry, and everything we have did. And of course, since it's a flexible, what is the bending angle? That how much flexible or how much time it has retained its stabilities. That we have to find out. So that also we did, and it has got published in 2021 Materials Letters. And recently we have published on the same journal on breathing sensor, and different work we have published. And of course, there are some recent, this is what up to now I have used using a biopolymer electrolyte. What are the different work we can proceed. And of course, I would like to discuss some recent work, what it's going. You see that particularly in energy field, sustainable energy, you can get a very good work. And water purifications, you may get a plenty of job opportunities and plenty of funding opportunities. And like that, diseases, of course, recently regarding COVID-based, means they used to give a grant immediately. There are many, these are the 10 different opportunities where you can apply the grant, apply the funding of agent, and you may get a grant. And of course, you see that particularly in renewable energies, because the petrol price, it's become a big amount of spending. Each and every government, not only in India government, in abroad also, they are worried about why this much money we are spending for this petroleum products. That money, why can't avoid that? We can try to use it for some other purposes, either to develop the countries. So that's why very so much amount of money it's available, particularly for solar and wind, renewable energy, right? And small hydro and biofuels, hydrogen productions, renewable energy. So this much amount of money it is involved, and this much world investment in different form of renewable energy. So total $2.6 trillion they have invested, particularly in just you can Google it. In India, each and every company, either it might be Exide battery or Amaran batteries, everyone want to find out the lithium ion battery, how to prepare the cathode material for lithium ion batteries. They are working. And of course, these are the electrode materials are available. Carbon material with high surface area, carbon fiber, graphene, activated carbon, right? And high surface area and organic conducting polymers, inorganic metal oxide, metal sulfide, MOF. Recently, one more work it came, covalent organic framework, that also it's going, and MXing metal halides, that also those type of electrode material we are working. So activated carbons and carbon nanofibers, we are synthesizing and fabricating, and of course graphene also we are synthesizing and fabricating. Conducting polymers, polyaniline, polypyrrole, polyethylene dioxide, and metal oxide, particularly catalysts, hydrogen evolution reactions, oxygen evolution reactions, gas sensor, breathing sensor, Yamaxing also one more work we have completed. Not only this, now we are that fabrication techniques we have improved. Instead of now recently we approach only screen printing. The next technique we are trying for inkjet printing. Next we are trying for 3D printing. So when you are doing a 3D printing, the device it has shows 100 milliampere, small device can able to give, I shown no, for the 0.5 centimeter squared electrode might be comes to 50 electrode farad per gram. Now for a small device, if you fabricate in a 3D, it might goes for even 800 milliampere to 1 ampere. And of course multi-layer depositions, we can take a carbon fiber and continuously deposit the conducting polymer. First, you can use a one dopant, and a second in a different dopant, and third one different dopant. Because this is under what do you mean by that means? Why I am trying this means? So we want to get a high capacity material. That's what the aim, right? We are trying to achieve in different methods. How to achieve means multi-layer coating you can try. So one student completed PhD and sees a faculty in the same institute. And hydrogen evolutions. So metal normally for the hydrogen evolutions we have to use for the platinum, but platinum it's very high costly, we can't be able to use. What we did, we have synthesis metal oxide and metal sulfide based good electrocatalyst, and we are provided the carbon act as a conducting support. That support, due to that support, it has shows some good efficiency. Of course we can't reach a platinum, that it is highly impossible, but that is one of the good method to get a good catalyst. And of course these are the fundamental again where it has to be received. And next one is the recent work, we shifted to the dye-sensitized solar cell and perovskite solar cell. So dye-sensitized solar cell, we are synthesizing a new organic sensitizer, the same concept only. Here the dye it will come. So these are the recent trend in the various solar cell efficiency. This you can came to know that of course it's very difficult to reach efficiency with respect to silica. Silica is always it's a top one, and that's why we can't able to replace the silica based solar cell. Of course there are other method also it's going, particularly perovskite and dye sensitized solar cell also. And same method only, supercapacitor, how you are going to do that. But here the slight difference is photoanode and photocathode, and in between you have to use an organic sensitizer. The organic sensitizer, it will capture the sunlight, and after some times it will regenerate the inside it, and it has to be work takes place continuously. And here also you require the polymer electrolyte, the same what I have used in the previous, no, that I have used for this one, but I went for the different applications. I used the synthesis of photoanode separately, photocathode separately. Then organic one student came. As per the student interest, we have given organic dye. You can prepare the organic sensitizer for fabricating a dye sensitized solar cell. So this is a proton donor and acceptor concept. One donor will be there, one acceptor will be there. So that might be helpful to enhance the efficiency of a dye sensitized solar cell. But dice, even though whatever you attempt you did, it's very difficult to increase the efficiency of dye sensitized solar cell more than 2% to 4%. But of course, we did some good approach and very good review articles we have written in this renewable sustainable energy 18 impact factor one review article is there, and Journal of Power Sources, International Journal of Energy Research, and other than the Journal of Electronic Materials, some small review also we have written. That under it might be helpful for your further studies. And this is one simple molecule, so I am saying, telling how the proton donor and acceptor will be there. So that organic sensitizer we have used as a dye molecule to fabricate the dye sensitized solar cell. So this is the fabrications. First you got to clean the electrode and identify FTO electrode which side is the conductivity side. Then you can apply all the things, silver doped, and thereafter you got to do a sintering. Then after that sintering you may get this color. Then you got to again your biopolymer electrode you got to peel off over the electrode. Then photocathode you have to coat it in another side, that you have to keep it here so that it might be becomes. And of course again we did the integrations also. One side in the FTO plate we have fabricated dye sensitized solar cell, and another side we have fabricated the supercapacitor. The same thing, activated carbon, the same electrolyte you can show. So what is the idea behind that? The energy from the solar cell, because solar cell it is an energy conversion device, you can't store the energy. So whereas supercapacitor energy storage device, whatever the energy you have to store in the supercapacitor, that we did the integration and it has got published in Journal of Solid State Electrochemistry. And next one is the recent work in perovskite solar cell. Of course, the method is very tedious, easy to synthesis. The perovskite it's highly unstable, and within 3 hours you have to complete the works. And recently we the 2021 we have published solar energy one review article. Another 6 to 7 papers we are going to communicate, we are fabricating, and one paper it went to review in Applied Materials today, 10 impact factor in perovskite solar cell. The same concept only, here that electrolyte it won't come. Instead of that you have to take a synthesis of perovskite, so E tier and H tier. And the next one is the recent work, very good money it is involved in the lithium ion cathode material preparations. So the first cathode material, lithium ion phosphate, so that it comes to current density 130 milliampere per hour, and cost is less. Due to that they are using for scooter company, because at least they can give for if 10 racks if you give put it for one scooter, no one is going to buy. That's why all the scooter lithium ion based vehicle they are using for this one, lithium ion phosphate. And the next one is lithium Mn2O4, but in high voltage electrolyte will get decomposes, right? And that problem it is the maximum things they are using for the car. And next one is maximum things they are using for lithium cobalt oxide and lithium MnO2. Here also high voltage the electrolyte will decomposes. That's why they are telling every 5 years you have to replace the battery, they are telling. So that is a limitation for the lithium ion battery vehicles. And next the recent work, another 5 minutes I am going to complete now. So thermoelectric generators we are preparing. The same concept only, but slightly different. We are preparing the organic and inorganic ink. Then we are using a thermoelectric concept, that is two different concepts. Material A and B will be there. When you are passing at two different temperature, you might be get a, due to difference in temperature, you might be get a different electric current. Or when you are passing the current in a two different material, either it might be absorbed or expelled. Due to that, you may get a current. Using that, this concept, we are fabricating the thermoelectric generator in a screen printing method, and we are doing the fabrication and testing. And recently energy one article it got published, and one more in Jercom it got published. So these are the different material, and of course flexible micro humidity sensor, and a breathing sensor we did. In N95 mask, if you keep this sensor to the N95 mask, you can came to know that the doctor can able to identify whether the patient is doing a normal breathing or a deep breathing or agitated breathing. Easily they can identify. Now how they will identify means they will see the patients how the breathing is there. Using that they can identify. Now we have developed the device, so if you keep it in the mask and tell them to breathe, it is connected to the smartphone, and doctor can able to identify with the help of pattern. They can identify whether what type of breathing is there. And flexible micro super cap, that already I have explained that, and various applications. So these are my groups. So the first students completed 2014, and he became a faculty in the. He has joined 2020 in the same department as a faculty. And 2019, one more student completed, and she's joined 2009 itself faculty here. And recently, one student completed 2022. And Ramakrishna Naik is working in thermoelectric generator, and he is working, Devraj working in organic sensitizer, and this girl is working, Maidri is working teloscopic material, and one more faculty working in thermoelectric generator. This student only got IAS Best Project Award for the BTech student, and this student work is going, and recently one more work we have started using MOF for all the inkjet printing, 3D printing, and one more student is doing, I didn't put, he has to, yet to register the PhD. And these are my mentors, and thanks for your valuable observations and patience. And the recent work, just for give awareness only, because we can't stop it only biodegradation. For that reasons I put. So the forum is open for the discussions. If you have any questions, you can ask now.
Yeah, very good, Dr. Sir. Yeah, past 2 hours, very nice presentation for topic of molecular interaction of synthetic and biodegradable polymer, plastics biodegradation by blending with the biodegradable polymer, sir. So very nice presentation for past 2 hours, sir. Some participations for some few questions is raised there, sir. So
Yeah.
first questions, yeah, enzymatic degradation is the best route for biodegradation, sir.
Can you repeat the question, sir?
Yeah, enzymatic degradation is a best route of for biodegradation.
Yeah, definitely, sir. Because instead of the bacteria producing the enzyme, directly if you add an enzyme to the polymer blend films, the degradation rate might be very high. But still, you have to prove that whether the synthetic polymer get degraded or not. Yeah, definitely, enzymatic degradation is the best method for degrade the plastic plate.
Okay, sir. Thank you. So other participants questions one by one question, sir. So
Yeah.
whether biodegradable plastics are completely degradable in a natural environment, whether we need a separate arrangement for making it to be a degradable.
Uh, yeah, it is very good question, because in the environment, everyone has a resistance to degrade. So some condition has to be required to degrade the material. Of course, if there is no conditions, the degradation's time it might be taken longer. But compared to synthetic polymer, the natural biodegradable polymer, it will degrade in the environment, and there is no proper conditions. If we are not giving, the degradations time might be takes place very high. So instead of 1 month degradation, it might take place 2 months, but completely degrade. But respect to the molecule of your molecular moiety of the molecules. So if you take a polylactic acid, yes, definitely it might get degraded. But if you take a synthetic biodegradable polymer, you can't tell 100% degradation. There will be certain limitations.
Okay, sir.
Yeah.
Okay. So another questions. What is your time duration for bioplastic to degrade? Can you say which kind of bioplastic takes soon and which kind takes year to degrade?
That's what, sir. We can't normally that respect to what is the environment it is there, with respect to what type of reactions has takes place. If you give a proper conditions, might be degrade 3 to 4 days also. If there is no conditions, might be the life of the polymers might be enhanced. So, with respect to what type of conditions and what type of applications, where either you prepare the plastics packaging material applications and what type of applications you did, with respect to only we can tell. So we can't tell within a day it will degrade.
No.
Yeah, I hope I answered that.
Yeah, oh, yes, sir, yes, sir. Okay,
Consideration.
sir, sir.
Yeah.
Actually, the shelf life of the biodegradable plastic made out of polylactic acid and PBAT and etc. It is a composite mixture for
Yeah.
specific
Yes,
application design. For example, carbon industry, optical parameters very important. Transparency is one of the criteria. Subject
Yeah.
then apart from mechanical strength and etc. is there.
Yeah.
And actually, we recommend the product to be used well within 2 months. If not, what will happen? It will automatically undergo self-degradation with the environmental condition itself because polylactic acid is very prone to fix up moisture like anything. That's why if it is seen applied for deployed in food packaging industry, it's very difficult to preserve the food what is kept inside. But same thing goes with garment industry also. For example, if you supply to Tirupur and they pack the material, t-shirts, etc., and exporting to various countries, it takes minimum 30 to 60 days to reach the destination. By the time, slowly it started degrading, it become powder-like thing. So now we are working on it to improve the shelf life without compromising the biodegradability of these PLA and PBAT based biofilms. So we can safely say 180 days is the shelf life of biodegradable plastic as of now available in the market. That's the thing I want to add value to
Okay,
this
sir. Okay.
answer.
Thank you so much, sir.
Thank you.
okay, sir. Very, very nice information,
Yeah,
sir.
yeah,
Vijay,
nice
sir.
information,
Thank,
sir.
yeah, thank you, sir. So, any other question, participants?
Yes, sir. Good afternoon, sir. It's a very good presentation. I am Professor Dr. T.R. Prabhakaran.
Yes, sir.
Yeah, yeah. You mentioned that the degradation you can see in the moiety.
Yeah.
My first question is, sir, can we see the degradation starts at the first day or the second day or the third day? You mentioned that
No,
the
sir.
all the
You
fifth
no, sir.
day the degradation takes place.
Yeah. Yeah. Go ahead, sir. Yeah.
Yeah, that's my thing is the
Uh,
degradation starts from the first day can be observed or the fifth day the entire
No,
degradation
first
takes place
day
only.
very difficult to find out, sir. Particularly way classical method under we can't able to find out because
Very
uh,
good.
the weight might be increased. If you see that the first day, if you take a film and if you did the weight loss method,
Okay.
definitely the weight might be higher than that of the previous day. So at least you have to give for 5 days and make it proper drying. Thereafter,
Okay.
if you did a weight loss method only, you may get a proper weight. And you have to do some 3 to 4 times the whether you are getting a same weight or not. Then only we
Okay.
can tell it might undergo degradation. Otherwise, we can't able to tell. In the first day under, it's very difficult to tell.
Okay.
Sir,
Okay, sir. Thank
actually,
you.
by seeing itself, once it started degrading, the optical parameter, what we measure is the transparency in haze value,
Yeah, yeah,
percentage haze value, you may be knowing that
Yeah.
by looking itself, we can see it will slowly starting opaque. So the day one, once the product is manufactured, it will be very high transparency and having a good low percentage like 10 to 10, 15, 13% haze value will be there. By just by visual, normally by seeing itself, we can able to find out slowly because it will slowly become haziness will be there. This cloud-like formation will be there. That itself is a small indication your product has started degradation. That's it's
yeah,
only a eye observation.
yeah,
That's
yeah,
it.
yeah, yeah, sir.
Fine, sir. Thank you, sir. Thank you.
Yes, is any other questions from audience side?
Sir, good afternoon, sir.
Yeah, good afternoon, sir.
Really amazing, sir, for your beautiful and energetic presentation, sir.
Yeah,
Sir,
thank
I
you.
want a general question, sir, as individual
Yeah.
or as a public. Okay, sir. Sir, tell the how the rate of the health hazard will be minimized by the utilization or introducing of the these kinds of bioplastic, then the non-bioplastic, sir. It is very important one, sir, because by the usage of plastic, generally, doctors society will be aware the public risk of cancer rate is high, so that our government. Encouraging other scientists to minimize the plastic just found one more new plastics rather than the this kind of carcinogenic diseases. So please
Yeah.
comment about it, sir.
No, can you come back again? I couldn't get the first questions, please. Neerakandan?
Sir, he is
Hello.
asking that whether this bioplastic can reduce cancer. It is safe like that.
No, I don't have any idea about it. Those things and that I couldn't study. Even I couldn't go for any research, literature survey also. So might be hopeful because you see that that's what I when I was presenting the introductions I told you. One of the article Chemsosphere that author has written. He has did 30 years of studies in polyethylene for biodegradations. He couldn't find out a small degradations in that. That means imagine that he give a proper conditions also, but in the end of 30 years he is writing that article still I have, right? He is writing and give a proper conclusions he couldn't able to find out. So might be if he decrease the plastics might have a chance to the cancer activities may have a chance to, but since I couldn't do any literature I can't able to give proper comments in that one.
Sir, shall I add some point
Yeah,
to
yeah,
this
yeah.
question?
Please answer. Yeah.
Gentlemen, actually, you asked about whether the synthetic plastics made out of petroleum base is going to cause carcinoma in
Yeah.
human beings, right?
Yeah.
Actually, cancer is not a disease, it's a disorder, first of all. Actually, what happens in our human cell, every day, thousands, billions of cells are decaying, and exactly same number of cells has to be generated by means of what everybody knows cell division mechanism, prophase, anaphase, metaphase, and telophase.
Yes, sir.
4 cell divisions there and keep on. For instance, if you are losing 1 lakh cells a day, actually again 1 lakh cell has to be rejuvenated. There is a mechanism in the human system, what we call it as contact inhibition mechanism. If at all the cell growth is more than the required amount or decayed amount, then there is no space for the extra cell to be fit in. Otherwise, you have to go on the second layer. It is not possible. What happens? That's called immediately it will sense the system to stop producing extra cells. What happens? The synthetic plastic like polyethylene, polypropylene, by means of biodegradation use of enzyme produced by certain microorganisms like bacteria and fungi, it will degrade and becomes microplastics. That will become very fine powder. It will fly in the air. It will go into your nostrils, deposits in the lungs, and leads to lung carcinoma. It is there. That's why it is very, very dangerous if it goes to a microplastic. It has to be completely degraded or it should be left as such in the universe. In between is what will happen, it goes inside and trigger the, or it will stop the, or it will collapse the control mechanism of the body, which leads to excess development of cells, which will over deposit on the layer of monolayer of the cells, which is nothing but the tumor. That's nothing but what we call it as a carcinoma. It may be in any place. It may be lung cancer or adenocarcinoma, anywhere throughout the body, wherever it may go and start at primary, then goes to secondary, etc. etc. Okay.
Yeah. Yeah, I to add in this, we have worked out from the plastics PET bottle, we have synthesis activated carbon. What we did, we collected the plastic bottle and make a fine small surfaces, and thereafter we burn in the oven some 600 to 700 degrees Celsius, because we got to see that when it will become a carbon and when it becomes ash. If it becomes ash, you can't able to convert it to activated carbon. That very difficult to remove that microplastics, because fine particles it will be there in the carbon itself. We can't able to remove so much times, in nearly 6 to 7 months we struggled to remove the microplastics. Then it became an activated carbon. That work was very tedious. In fact, we did that work and it got published in jercam 2022 2020. You can find out that articles. It's very everywhere that carbon, it became a carbon, but still you can find out the small microplastics in that. Then we tried and we can try to able to, so finally we couldn't succeed at all. We have written in that and some small microplastics. Then we did what happened in a running water. We continuously run for water circulation. Of course, if you did the running water, the water it might be become waste. So continuous circulations we have given in the lab. We tried to wash some 1 month we washed. Imagine that 1 to 3 months. Then only the plastics it went off. Thereafter, we got activated carbon, then we fabricated the device and checked. Yeah, it was interesting information, sir. I thankful to you.
Sir, thank you.
Any other questions, audience? I think the questions are over, sir. Shall we close the session, sir?
Yeah, okay, sir. Afternoon I have lab 3:30 to 5:30, so I couldn't able to join. So you can, if Vijay Kumar talk, I try to attend because Sir is giving very good information. So up to 3:30 I'm free only. I try to attend the
Please, sir.
talk. Okay, sir.
I'm expecting your presentation. Thank you,
Yeah,
sir.
yeah. Thank you so much for
Thank you.
your valuable input also, sir. I try
Thank you,
to
sir.
attend
Thank you.
1:30 to 3:30.
Sure. Thank you.
Yeah. Any other queries? You can, I think Karthikeyan might have my email ID and my phone number. Any queries you can talk, and if you want to do any further work also, you can do that. I'm ready to help for anyone. Yeah. Thank you.
Definitely, sir. Thank you.
Thanks for your opportunity also to giving my talk.
Okay, sir. Welcome, sir. So, audience, you can again retain at 2 p.m. for the another session of today's seminar. So, it will be about enzymatic biodegradation of plastics by Dr. Vijay Kumar, sir. Thank you, audience. And those who have not filled the feedback link, please put it. It was already posted in the chat box. Thank you.
Yeah. Thank you.
Participants, if you have finished the feedback, you can leave the session. There is another session in the afternoon at 2 p.m. You can rejoin. Thank you.